Okay, hello, welcome everybody to this Chamber Low Carbon Live Lunch and Learn, building optimisation through AI and IoT. I'm Chris Gibbons, I'm the Energy and Environmental Advisor with Chamber Low Carbon Programme, or one of I should say. I'll be hosting today's session for you, and we have Giovanni Lupaldi, and he'll be speaking to you today to give his expert insights. Giovanni is from What's On Consultants. Before I formally hand over, there's just a little bit of housekeeping and information on the Chamber Low Carbon Programme itself. All participants are on mute. For questions, please see the Q&A facility at the bottom of your screen. You can submit these questions here during the session, and today we'll be answering these questions at the end once we've done the actual presentation itself by Giovanni. So nothing will be missed if it puts in. It also gives us the opportunity to, if there's any repeat questions through, it keeps the flow of the presentation going, and you also may find that your question is answered further down the line in the presentation. When you submit that question, if you'd like to answer your question personally, just let us know in the chat box, but come the end, I'd be more than happy to read it out on your behalf, or initially read the question out on your behalf, and then maybe if you want to follow up at all, you can use the chat, or we can unmute you. That's no problem. Alongside the Q&A, we have the chat function, and that's allowed you to introduce yourself, network, say where you're from, speak to the other attendees of the actual webinar. And today's session is being recorded, and it'll be available to watch again on the Chamber Low Carbon YouTube channel. Intro to Chamber Low Carbon for those of you that are new with us today. If you just move along to the next slide, please, Claire. And so we're a partnership programme, and that's with East Lancashire Chamber of Commerce, North West Lancs Chamber of Commerce, Business Wise Solutions, and Boost. We support businesses across Lancashire to go green, save money, and reduce their carbon footprint. We're part funded by the European Union Regional Development Fund. We're a £6 million programme providing a free suite of services to help businesses improve their energy and environmental efficiencies, introduce on-site renewable energy generation, and assist in saving money. The programme also helps Lancashire businesses who are developing new low-carbon technologies to bring those products to market, facilitate them being manufactured in Lancashire, and to help them find demonstrator sites within the Lancashire region. Now on to today's speaker. Giovanni is director and founder of What's On Consultants. He's a chartered engineer and environmentalist, a certified energy manager, ESOS lead assessor through the Association of Energy Engineers. That's just some of his skills. He's an expert in energy efficiency and renewable energy. Giovanni started his career here in the UK working on building physics for some big consultancy firms such as AECOM and Borough Happold. Industrial, commercial and energy efficiency and metering and monitoring targets technologies have been his focus in recent years, and he's responsible for the assessment and implementation of multi-million energy efficiency capital investments across the UK, EU, and wider areas. He also delivers national and international energy auditing programs for large blue chip organisations. I'll now hand you over to Giovanni.
Thank you very much, and welcome to all the people that is participating to this webinar. Today we're going to talk about how artificial intelligence and the Internet of Things can help factories as well as commercial building reducing their energy consumption. Claire, can you please change slide? So in this presentation, we're going to look at the current business situation in the UK, what challenges and opportunities are lying ahead. Then we're going to talk about how artificial intelligence and the Internet of Things can improve the way, in this case, energy and manufacturing, energy and maintenance are managed in these buildings. Then we are going to talk about the advantages of using artificial intelligence and the Internet of Things to reduce costs and improve environmental performance of factories and buildings, and some real-life application of these new technologies that are coming up. Claire, can you please change the slide? So, over the past 6 months, 27 UK energy suppliers have gone bust as wholesale prices have soared. The first one to go were those with a weak balance sheet strength, which could not take adequate hedging on their energy requirements. So in other words, suppliers we're requesting energy costs that, due to the recent spike into wholesale, could not actually be sustainable financially. The world energy consumption has more than doubled in the last 40 years as well, and it is projected to increase by another 30% by 2040. So there is a lot of pressure into the energy sector, not just in terms of prices, but also in terms of finding energy for customers. So Claire, can you please change slide? So what made me grow an interest into the topic we're discussing today is the complex nature of building management systems. Many simultaneous anomalous behavior warnings are not manageable in a timely manner. Therefore, many energy-related problems are left unmanaged, which causes unnecessary energy wastage and deteriorates equipment's lifespan. We also wanted to evolve conventional metering and monitoring and targeting system into something that prevents energy wastage, avoiding continuous external intervention. But to complicate the picture, as we can see from the slide, upskilling or retaining existing staff was the biggest priority for about 2/3 of companies involved into manufacturing in the UK, followed by new products development and capital equipment. Access to labor was seen as the biggest risk by almost 2/3 of manufacturing companies, while almost 9 in 10 companies were worried about losing skills for their business and the wider sector. So operating problems associated with degraded equipment, failed sensor, improper installation, poor maintenance, and improperly implemented controls affect many heating, ventilation, and air conditioning systems. And the lack of these skills, or the upcoming lack of these skills, is a big problem. So these factors led to inefficient operation, increased energy costs, discomfort, and increased wear of components, therefore reduced reliability and shorter equipment lifespan. Fault detection systems are nowadays playing a fundamental role in monitoring complex HVAC systems, but also manufacturing processes, detecting anomalous behaviors in such a way to keep this system in their best operational condition with minimum cost, because the process is nearly entirely automated. When unexpected anomalous events occur in manufacturing of HVAC system, their consequences can be quite damaging and costly in terms of money and time to be treated. Therefore, half of the companies in the manufacturing sector in the UK said they plan to invest in green technology and energy efficiency measures in 2022, which is a good thing, with a third saying this investment has already increased a third. A third of also said the transition to net zero has been accelerated by the recent COP26 conference. So energy is definitely a focus, and a lot of manufacturing companies in the UK are already looking into how to become more sustainable and energy efficient. Claire, next slide, please. Claire, thank you. So, based on what we have seen in my latest projects and feedback from clients, we are facing a very challenging period where the combination of several factors could potentially cause stress to commercial and industrial organization. Shortage of staff combined with recent trend of people taking a career change after the pandemic or leaving for a better paid job would undermine a company recovery from the pandemic, or reduce the necessary attention to lean design and efficient resource management. That is why we believe that artificial intelligence and the Internet of Things can provide an economical and versatile tool to compensate for these challenges that companies are going to face, with staff challenges, both in terms of headcounts and expertise, that might not be easy to find anymore. Claire, can I have the next slide, please? But let's take a look at what is already happening into the manufacturing sector. So, for example, let's look at a Lancashire-based company, BAE. BAE is actually at the forefront in Lancashire for what concerns the automation of manufacturing. So in one of their factories in the Northwest, where they are assembling jet fighters, they are increasing the share of the manufacturing process, which is led and run by robotics and artificial intelligence. So the challenge in the manufacturing process is happening. The change in the manufacturing process, is happening, and we are going to see more of real-time and on-demand production operation being carried out. But this should not be seen with skepticism, but more as an opportunity, because, as we said, lack of trained people, and also the cost of energy could be factors that could produce deadly situation for the manufacturing sector, and actually not allow manufacturing to be carried out anymore in this country. So AI and automation should be seen favorably in order to maintain production carried out in the UK. Claire, can we have the next slide, please? So it is a very common situation for many businesses we are collaborating with, in the sense that in our sector, that is that of energy management consultancy, very often energy and maintenance management responsibilities are added to the duties of staff which did not have these tasks in their job description. So in other words, people that is supposed to physically operate maintenance on some sites, or that are responsible for health and safety in other cases, are also given the responsibility of energy management as an add-on to their job duties. However, energy management is a bit of an art. It combines not only technical knowledge, but also behavioral knowledge. Behavioral in the sense of the people that live and operate in the buildings that should be managed from the energy point of view. So these people might not have the necessary training to carry out a good job in managing utilities, not only energy, but also water, and that is coming more and more of an important issue these days. But also to optimize maintenance operations at times, or make sure that these maintenance operations are done intelligently, proactively, predictively, as we will analyze further down in this presentation. And some people might not have the necessary skills to do that, and that's where most often we come into the game. Claire, can we please have the next slide? However, combined with the skills shortages in the manufacturing sector, and sometimes in the commercial sector as well, for what concerns engineers and technical manager, we also have the challenges of climate change and other environmental issues that are becoming more and more important, and therefore putting additional pressure on businesses. In the commercial sector, these are the hot topics at the moment. So, integrated sustainability. All businesses will be expected to have sustainability woven into the fabric of their organization. Dedicated experts are needed more than ever, but there is also a growing requirement for sustainability to become a part of everyday's, of everyone's day-to-day job, as we said. But the problem is, where do we find these professionals? It's really difficult to find a whole-rounded person that can take care of their job, for example, health and safety, and is he able to deal also with energy management, as we just said. Number two, disclosure and reporting. The UK has made sustainability reporting and disclosure mandatory. Data will be needed if we are to meet the pledges made at COP26. So, does your company have somebody that can do that? And how can you demonstrate improvements you have achieved through your energy efficiency program? Do you have the data analysis? Well, does your personnel have the data analysis skill required to do it. Standardization. There are over 400 sustainability standards, benchmarks, and certification protocols which organizations can voluntarily choose to adopt. Industry standards are important tools to provide transparency, and they level the playing field across organizations, but it's a complex and confusing landscape for many. To cut through the confusion, a streamlining of this kind of certification process is expected to be called for by many sectors. So the main question is, which sustainability standard shall any company use to obtain best value for money? And which one is best suited for each company to avoid a wasteful greenwashing? Last, energy risk management, as we just said. The 2021 energy crisis is far from over and is only set to get worse. Globally, as we shift to a lower carbon economy, moving away from coal, we will see an increase in the uptake of gas and nuclear power. The price of renewables derived energy will continue to fall, and reliability will increase, driven by technological advancements and widespread adoption. So, although the cost of fossil fuels is increasing, renewables and renewable energy generation will go down. However, these also come with challenges: the reliability of power supply in the grid. If most of the buildings today are using still natural gas to keep their building and processes warm, but there will be inevitably absence of this source of energy in the near future. So do you have a plan for the shift to a low carbon business? Do you know what is the real capacity of your manufacturing support services or your HVAC to replace these with optimized low carbon technologies? So as you can see, energy and decarbonization are becoming more and more relevant, both for manufacturing and commercial buildings. It's not just a matter of having to manage 3 to 10% of your business running costs anymore. This is going to become something that is critical to keep operating your building or your factories in the upcoming years. And it is a good thing, and probably something recommendable, to start getting ready for the energy transition, not just because cost of energy could become unaffordable in the near future, but because energy will be a critical issue to carry on with your activities. When gas won't be available anymore, you will have to swap from fossil fuel based to renewable energy based processes and deal with associated costs. Claire, can you please put the next slide up? So several factors are driving companies toward a digital transformation. So acceleration to change. So the pace of digital change is definitely rising. More and more automated and interconnected processes and machines are used both in the commercial and manufacturing sector. Digital competition. Born digital startups are impacting long-standing organizations. So there is definitely an advantage in being connected, use the Internet of Things to carry out your own activity, and that is going to give commercial advantage over your competitors, certainly. And customer expectation. So innovation, connected products are no longer luxury items. They are a must-have across entire buyer spectrum. So clients are expected to have more direct visibility of what is happening into your factory, have clarity on when products are delivered, have the opportunity to have a say in how buildings are operated, and have transparency of what is going on in the building they're using. Claire, can we look at the next slide, please? But what are the components of these digital transformation? There are 3 main building blocks that are associated with this transformation. So data analysis is critical to identify margin for improvements, and therefore cloud computing. We need to have a way we can collect data related to how processes and buildings are operated. Then artificial intelligence is the only way to process vast amount of information economically and producing, gathering, and act upon all the results of AI to actually improve the processes. So getting data is not something that is going to solve the problem. Given the vast amount of information that can be collected through automation, it is inevitable that artificial intelligence will have to do something with that vast amount of information and get something valuable out of that. So true digital transformation depends on how we leverage these technologies to drive business faster with greater business outcomes. And automation, it's also going to help in that sense, feeding from whatever comes out of artificial intelligence. Some routine operation can become only economically possible if robots and automated components can react to whatever comes from the results of artificial intelligent processing. Claire, can we look at the next slide? So post-pandemic, based on survey into the manufacturing sector, the business priorities are: number one, reliance, and number two, automation of processes. It has been found that for manufacturing companies, automation will enable future resilience, with 50% of these companies anticipated that half of their current business processes will be automated by 2025. So it's only 3 years from now. 85% of companies are planning to increase investment in business processes automation, while 81% agree that data-driven management is essential to stay competitive. Watson Consultant as a company has moved into that direction of automation and AI-driven management for the energy management sector as well. So it's not just into the manufacturing commercial management of buildings that these automation and artificially intelligence-driven processes are taking place at a very fast pace. But it is also in the consultancy sector that we have seen a massive shift toward this technology. Claire, can we look at the next slide, please? So, if energy is a very hot topic and should be looked with a lot of attention, to achieve energy efficiency improvements, building maintenance and management approaches must be improved and optimized, and we believe through artificial intelligence. Facility management will massively benefit from real-time, accurate and comprehensive data to perform day-to-day maintenance activities and to provide accurate information to top management. However, the activities of inspecting facilities, assessing maintenance, and collecting data are labor-intensive and time-consuming if not carried out through automation. This fact, combined with the previously highlighted scarcity of trained labor, creates a serious obstacle to keeping energy consumption in companies' premises under control. So if we look at Europe, 40% of energy consumption is associated to building in this region, with 28% of total direct and indirect CO2 emissions. A large part of this energy is consumed by building installation, mainly cooling and heating system. However, the faulty operation of air conditioning or HVAC in a broader term can cause up to 20 to 30% increase in building energy consumption unnecessarily. To follow up on these statistics, it has been proven that between 5 and 13% or even 20% of energy consumption could be avoided by having a correct diagnosis and reporting of HVAC system. These percentages of potential energy savings are in line with the results we have measured at our clients' premises. It has been found that HVAC consumes approximately 41% of a building total energy consumption. They may vary depending on what type of building we're dealing with, of course. Whereas lighting is the second highest energy consumption unit, which expands around 29% of the total energy used in a building. Subsequently, water heating, office equipment, and other energy consuming appliances could add for another 8 to 13% of the total energy consumption of a building. Obviously, these percentages, as I said, vary depending on the type of building we're dealing with. However, the budget and resources allocated for building maintenance, meaning also the management of the building management system, for example, are usually limited, and maintenance personnel argue that their budget and resources are insufficient and below their needs. Possibly argue also that they need to be trained in order to operate building services correctly. This trade-off affects the quality and relevance of the maintenance activities and inspections in buildings, which lead to poor maintenance, quality management policies in facilities, and consequently, energy wastage. So probably from the building you are sitting today, excluding if you're working from home, your house, there is plenty of energy that can be saved just by making sure that the setting of your heating, ventilation, and air conditioning is set correctly, that faults are detected and acted upon, which is quite a substantial amount of energy and money that can be saved by having an expert look into how your facilities are managed. And by facilities, I don't want to imply those of a commercial building, but also wider manufacturing production lines. Claire, can we look at the next slide, please? Claire, sorry. Thank you. So what is the definition of smart ventilation? As we said, that HVAC accounts for sometimes the net highest contributor to your building energy consumption. So smart definition of ventilation is a process to continually adjust the ventilation system in time and optimally by location to provide the desired air quality index, internal air quality that benefits the most, minimizing energy consumption, utility bills, and other non-internal air quality costs. So the sad truth is that what is meant to drive a smart ventilation system, your BMS, very often is unable to do so, or is sometimes corrected by manual modification of its standard operation to resolve complaints or design defects, complaints from the occupants of your building, or design defects that were created when the building was built. For this reason, fault detection and diagnostics is attracting a vast amount of attention from building operators, because it can help greatly improve the performance of building operation by reducing energy consumption for heating, ventilation, and air conditioning, while also improving occupant comfort at the same time. However, for building operation, building operation remains with a lot of challenges to the special operation environments of HVAC systems. So one HVAC system will not be suitable in every single circumstance. Everything depends on the type of process that you carry out in your building or the type of occupants you have in a specific place. These challenges include tolerance or ignorance of failures in long-haul operations, lack of operation regulation, or even lack of documents for HVAC failure mode and effects analysis associated to the operation of the HVAC system. So to address these challenges, we analyze through automation common building HVAC equipment by exporting work orders generated by your building energy management system, so your BMS, and use this data mining to identify issues which are not the same errors and faults that your BMS reports in a normally operating BMS. With this approach, it is possible for building operators to isolate and prognose faults practically. The fault detection approach also helps us tackle high impact failures for which operation data can be used to enable machine learning-based predictive models, which we will talk further down in this presentation, and save you energy in turn. Claire, can we please have the next slide? So this is how all we have discussed about automation and AI, the Internet of Things, apply to what we do on a daily basis. So the sketch that we are reporting in this slide show how we currently support manufacturing and commercial buildings in their daily operation. A data hopper can be installed, and these sends through protected protocol almost in real time and at various intervals data from production lines and HVAC system to a cloud. This information identifies problem before they become critical and maximize equipment efficiency and reliability. This data provides a strategic approach to energy reduction using root cause analysis to streamline issues remediation. It also detects equipments operating outside of intended schedules or mechanical failures, point configuration or data errors, or suggestions for more efficient control strategies. So all this information that come from process lines, manufacturing lines, or building BMS is gathered by a very simple device that can be integrated into your system that sends this information to a server, probably in Iceland or somewhere where it's cheap to run this service. This data is then processed through artificial intelligence that is built in a normal fault detection and diagnostic tool. And that vast amount of information is digested and reported in graphical form for whoever works in the factory or for a consultant to look at and find what goes wrong. The benefits of this analysis are the creation of a framework to manage energy. At least this is in our industry what is happening. Produce cost, energy, and carbon reduction because you're managing the processes continuously through the application of artificial intelligence and in real time. It produces higher organizational engagement as the operation or maintenance team are deeply involved into the process of setting the device up, contributing to what data should be collected according to their feedback, and have the possibility of looking at the graphs and information generated by artificial intelligence and act upon these. It can help with the benchmarking of your building operation or manufacturing process. It can improve the reliability of your equipment and increase resilience for your building or your manufacturing process, which are all topics that we've discussed earlier in this presentation as being critical for the future of your building portfolio or manufacturing facility here in the UK. So we install data hopper that's sent through a protected protocol almost in real time, and as we said, various frequencies data directly to our artificial intelligence. So this process can establish the baseline. So what should be the minimum amount of energy that your facilities or buildings should use? It can identify significant energy using equipment and track their performance, create a data collection plan to demonstrate energy performance, develop energy maps, and identify non-conformities, so faults, wrong settings at their root cause. So support implementation of corrective action in an organized fashion and clearly identify where problems occur so that they can be acted upon. And also provide that kind of measurement and verification, which is so critical in the upcoming future, where companies are called to demonstrate how they are actually achieving their targets, their pledges into improved energy efficiency. All these steps are also key parts to meet ISO 50001 compliance, which could be achieved and maintained using a suitable platform at minimum cost. So artificial intelligence can not only reduce your energy consumption and improve your performance, but can also give you a cost-effective tool to meet certification compliance. Claire, can we change slide, please? So how does the application of artificial intelligence and the Internet of Things takes place within a commercial building or a factory? So what we're looking at on the slide here is a screenshot of a typical BMS window that reports the operation of an air handling unit. But this can apply also to manufacturing process, where perhaps it is your SCADA that is controlling, your SCADA system that is controlling how you are operating your manufacturing line. The steps that are usually followed in integration of a fault detection diagnostic system are the identification of data to collect. We usually work a lot alongside your team, your technical team, and have them to have their say on what are the most valuable data that we should get out of building management system or SCADA system. We need to understand what are the client's engineering infrastructure, what is the client engineering infrastructure in doing that. So there is a bit of preparation work that goes with the process. There, we need also to identify and design what is the best data collection strategy, because nowadays some parts of your building services or manufacturing line are already integrated with Internet of Things, or other devices that are collecting information. So we don't want to reinvent the wheel. We want to use what already is available on your site and not add additional infrastructure which is unnecessary. But we also need to understand with which frequency it is worthwhile collecting this data. So there is a bit of work that goes in the setting up of automation in data management for industrial and commercial buildings. So it is highly recommendable to complete these steps working closely with your engineering team, having also their feedback about what is important to be monitored. And I cannot stress enough on that. Then this relevant data is used to create reports, which are useful for your site team, as well as for the identification of wastage. And on this data, the energy consumption analysis is carried out. And once we do that, together with an analysis of how the parts of your manufacturing process or your HVAC are operating, we can also identify where you got faulty components, therefore establish correction procedures that can reduce your energy consumption very quickly without finding out months down the line that your gas or electricity consumption have gone up and you don't have any idea why that has happened. You can only see the effect of these faults, but nobody was there to catch them as they materialized. Claire, can we have the next slide, please? So these are typical issues that we identify within a heating, ventilation, and air conditioning system. But the same kind of issue we have spotted in manufacturing processes. So these are the usual suspects. These graphs represent only a small sample of the issue that we picked by using our fault detection diagnostic platform. So these graphs obviously are too small to read, but I can comment through what we found. Simultaneous heating and cooling in the same place. So because there was a wrong temperature setting applied to a specific area, the heating and ventilation air conditioning system was fighting within itself to maintain that very tight temperature, therefore having units cooling and other units heating the same place in the same time. Temperature overshooting. So instead of providing a suitable air temperature in a specific place, the system was probably overwritten to increase that temperature, probably due to a complaint for occupants. It was never reverted to normal operation. Things that have been left on when they weren't required. Valves that got stuck into position, so therefore they were faulty and therefore providing heat where it wasn't needed. But the BMS didn't pick on that because the signal was to close the valve, and the valve reported as being closed, but physically was stuck in an open position. Loss of efficiency, equipment that was running outside operational hours, but also programming issues such as the non-following of weather compensation setting into your BMS. Sometimes the BMS is set to provide variable heating flow temperature into your heating system depending on the external temperature. But although these functionalities in the BMS, and the BMS was supposed to be set with that functionality, that doesn't happen in real life. So all these technical faults and issues are currently detected by AI, such as that we have developed for Watson, our metering, monitoring, and targeting and fault detection and diagnostic platform. The use of software to continuously monitor the operation of plants and building services is reducing the contribution of consultants, human consultants, in the data analysis and fault detection identification, which brings down the cost of this sort of services and make these operation cost effective for clients. So you won't have a physical person looking at this data all the time, but artificial intelligence will identify these issues as incurred and notify relevant people on where these occur and how to mitigate them. Claire, next slide. However, for as much as artificial intelligence and automation can bring a positive impact on energy management practices, humans are still needed. Humans are still needed because we need humans to set the system up. We need humans to set up artificial intelligence. It's not something that is constantly evolving by itself. We need humans to contribute to which data is relevant to be collected. We need humans in order to establish the connection between our devices or devices in general and the cloud and the software. We need contribution from the directors of manufacturing facilities and commercial buildings in acting upon faults, maintenance issue, and provide the necessary funding to get this rectified and therefore save energy. And we need collaboration from your facility management team in order to act upon the alarms that are created by software. So robotics, unfortunately, are not there yet to fix a passing valve, but humans are there for that reason. But people that is employed to maintain your plants will carry on doing what they're employed for without having to worry about other things, because artificial intelligence is there to take care of that stuff. Claire, next slide, please. However, we talked about fault detection and diagnostic, FDD. However, there is a missing P that should appear at the end of the acronym FDD. That P stands for prediction. Nowadays, maintenance practices in the field of facility maintenance are mainly based on corrective maintenance. So late actions are taken following a user complaint or an unplanned failure. The lack of budget and human resources, as we just discussed, limit the use of preventive maintenance to the minimum level of mandatory inspection and critical installation. Moreover, the concept of predictive maintenance is based on processing the operation data sent by sensor using data analytic techniques. This approach offers the possibility to address the gap in maintenance practices by supporting the facility management team to take early action and avoid unplanned failures without the need for costly, intensive site inspection of the installation you've got on site. The introduction of smart devices, so things that are connected to the Internet of Things, to be clear, now allow for the connection of physical assets and real-time data transfer together. As a consequence, the field of operation and maintenance management is evolving. Classical maintenance approaches, which is based on reactive maintenance, so something occurs and you act upon that, are now evolving into something different, into something that is called predictive maintenance, thanks to machine learning, which is what can I say, an evolution of artificial intelligence, or a different application of that. The industry of facility management can benefit from the rise of machine learning and Internet of Things in order to improve the management of assets and reduce waste. In other words, there is more we can do with the data that we extract from the day in, day out analysis of your HVAC and manufacturing processes through a fault detection and diagnostic tool. Claire, can we change slide, please? So maintenance approaches can be summarized in the following three main categories. So corrective or reactive maintenance, which is what I just described, which is taking action upon something that got broken already. Two, preventive maintenance, when preventive measures are taken to avoid failures, for example, periodic inspection and replacement of equipment that looks to be about to fail. But as we said, shortage of staff and costs put a limit to this practice. Or predictive maintenance, which is when artificial intelligence and IoT system attempt to forecast the imminent occurrence of failure and intervene before it happens. Claire, next slide, please. So predictive maintenance is the upcoming revolution in facility management. Predictive maintenance can be declined into main approaches. So it can use two different type of, what can I say, settings to be driven. So there is a phenomenological or data-driven approach where the detection of an imminent failure is performed by learning the difference between normal and anomalous behavior into your system. Or it can be run by a model-based approach where the normal operation of your system are set into the artificial intelligence. When they deviate from that plan, you get notified that things are going wrong. So predictive maintenance can rely heavily on the creation of a very solid database to run efficiently. It needs models that are trained to recognize normal operation of individual parts of your system, but to date, and this is a bit of the holy grail for people working in my sector, doesn't achieve with 100% accuracy the exact time when things are, so it's not perfect as yet. None in the industry can actually have a system that can tell you by the minute of the day when a pump is going to fail, unfortunately. But if you have a fault detection and diagnostic tool into your business, the data that is extracted from that is not only useful to reduce your energy consumption on the same day, but in time is going to give you a database that is critical to apply what is the future of facilities maintenance, which is the predictive maintenance we just discussed. So it is still difficult to estimate ex ante the return of investment of predictive maintenance compared to standard maintenance approaches that companies are using today. However, the application of fault detection and diagnostic tool can give you what is required to make that happen in the near future. Therefore, having a facility management approach that are based on anticipating problem, therefore provide continuity into your process rather than having to firefight issue as they come around. Claire, can we look at the next slide? So we come to the end of this presentation. So to us and what we found through our work and working with our clients, digitalization is the only way forward. It is going to save you time and money in managing your facilities more economically, faster, and more efficiently. The manufacturing and commercial sectors, maintenance and energy management services will benefit massively from the Internet of Things and AI, and they can do this today with the current technology. However, humans are still needed in the process. However, sometimes we're also a limiting factor in correcting this issue when they come, because having to correct faulty equipment or act upon organizing installation of or maintenance activities is very time consuming and tedious. However, McKinsey, the famous consulting organization, confirmed in their quarterly reports that since 2000, over 50% of Fortune 500 companies have been acquired, merged, or declared bankrupt. And that's because of more innovative firms that are driving this digital transformation. So if you don't get on with getting your operation or part of your operation run by artificial intelligence or automation, you will lag behind and you will probably be take over in the best scenario. That's food for thoughts. And that's it. Claire, last slide. Thank you very much for your attention, and I hope that my presentation was useful and informative.
Fantastic. Thank you very much, Giovanni. Obviously, we're hanging around for a couple of questions. I've got some written down, see if any more come in. I'll start with one from the floor. So it says, so how are you different from other sustainability software companies like SCADA and Workiva? If I've said those right, that's from Michael Yin.
Well, that's a very good question. I don't know how they operate because we don't have any sort of sophisticated spionage network in place. What we price ourselves for is the personal approach we have with our clients. So as I said before, we set up a collaborative environment, setting up the system where we operate. So we take a lot of attention into the client's needs and what they think is worth monitoring, and we are always there to support whatever comes from the analysis of the data that we produce. So although we price artificial intelligence and automation, we still have the kind of human contribution to how we operate the business.
Yeah. Oh, good. Thank you. I've got a couple, see if we get any more questions. I know I've got some things I've been jotting down myself, just to sort of tag on to the back of what you're saying about kit. This is, most of mine will be focused reasonably around building services, but less so manufacturing, but this one suits both. How bespoke is your kit? How easy is it to integrate into a production line of a different manufacturer? Or if you know the element is a motor inside a boiler or a pump inside a boiler, how easy is it for you to tap your kit in to get that data out of those piece of equipment? Do you need, are you avoiding any warranties on the kit that's existing when that happens, or do you recommend the manufacturing kit or the HVAC kit as it goes in to have this stuff?
Okay, we are completely independent from any sort of kit that we utilize into this kind of application. So we can work with any BMS system or SCADA system as long as they are equipped to export data transparently. Right. It is very easy to implement these data hoppers as we define them. They are unbranded. So, well, actually they have a brand, but that brand doesn't associate to any other BMS system or SCADA system in place. They are very versatile and they are compatible with most systems. And the warranty on the part depends on the warranty on these devices, which I don't think it's a critical issue. We had these up and running for many, many years without any problems.
Yeah, no, fair enough. And I know you have covered it in your presentation, but say you're giving it the the hard/soft sell. Obviously, you've got something that's worthy to people. But if you're sat in an office and someone says, "Well, I've got a BMS. How's this going to enhance my life? I've already got some information that's coming to me. What is it that what are the key points that you're system that on?"
What I'm going to say could be controversial. The person that question is from a BMS sector. You might not like what I'm going to say, but nevertheless, I'm going to speak my mind. BMS systems are there to manage your HVAC. However, they can report error. That's fine, but they cannot look into their own defects. Our system is independent and is going to check how actually the BMS is operating your building, and perhaps how manual override of BMS settings are causing you issues. So perhaps it's not a BMS issue, it's like a human intervention on BMS due to a temporary complaint that messed the overall management of your HVAC. And that's where our system comes in. It picks up not just faults of the BMS, but also wrong settings, and how there is loss of control by the BMS onto your building, because the BMS, like any machine, in time loses grip, loses accuracy, and we're there to spot this issue when they happen. But we can also spot issue created by manual changes to the BMS philosophy because of a temporary complaint. And therefore, it's not just about checking the BMS, but making sure that settings are the best possible for your building. When BMS company, and I close with this, come to establish the BMS, they sometimes do not tell you which is the best way of providing internal temperature. They just want to have a system that works, and they walk away. We're there to make sure that since they walk away, we will make sure that you use the minimum amount of energy to maintain suitable internal conditions.
Yeah. No, thank you. No, it's very comprehensive in sort of, so just the way I was thinking is that's the best way to sort of detail it out, really, is really split the two, because in layman terms, someone might think they're a little bit similar. But obviously perfectly and comprehensively answered to prove that they're not. Let me just sort of check my notes here. Oh, sorry, there's one more coming while I consult my notes again in a second. Have you got any case studies that show reduction in utilities and costs from using your solution? That's from likely Ian again. Or any figures off the top of your head, and obviously if you've got somewhere to point us, I'm sure we'd have a look as well.
Yes, I have two. I can quickly talk about that. We got a manufacturing site in Scotland that is producing vaccines and other type of pharmaceutical products. They were absolutely sure that when the manufacturing process was not performing, so was not active, they would have switched off the cooling system associated to the reaction vessels that are used in the manufacturing process. Now, by looking at the real data coming from the chillers combined with the volumes coming from manufacturing, we realized that actually sometimes the chiller were left on, therefore pumping chilled water around the premises when there was no production happening. In turn, simply by switching off chillers when there was no production, which could have been identified through an alarm generated by our system, they could have saved £80,000 worth of electricity per year. That's on an industrial site. On a commercial site, we have achieved savings of up to 15% in an hotel, simply by controlling temperatures, make sure boilers respond in line with external temperatures, and switching things off when they're not needed.
Yeah. So for two very good examples. What do you find your biggest challenges is integrating or sort of cracking the nut of getting into the SME market? And obviously I know it's from a very small market to to pretty much 50 million euros. And it's wide and varied types of companies. But generally what your core market would be, the core people of say manufacturers and big consumers of HVAC that fall into that. How do you break down those barriers? And is it easier to get into sort of people that are landlord based, and you might have bigger landlords that maybe sit outside the SME market, but SMEs are in their buildings, and do they do it for them, your Savills, your Knight Franks, your Bruntvoods, or do you prefer to work with the end users that are directly SMEs?
No, I think this kind of change and follow up of whatever we pick up through our system has to be forced from the top. So ideally, to make our work be integrated faster and more reliably or more effectively, we need to really work with directors, people that is responsible at a high level for energy consumption. So financial directors, environmental directors that can promote the system and make their people understand why it is important to use us. The most limiting factor is making sure that there is a kind of push from above and force facility managers to improve the way they manage buildings through our, supported by our help, and make sure that once we identify issues, they are followed up and taken care of. Also, there are some issues always in making sure that your internet, the company that provides your internet access, is on board with this and is collaborative or helpful in order to get the data transferred over. So these are the really bottleneck, but we can get over them by a bit of planning.
And what's the preferred or best way of going in, or is it really a case-by-case basis? Is this kit best going in when you're going into your new premises, whether it's a new build or you're fitting out a new place, or is it better retrofitted when all windows, doors, partitions, people, sort of arguments about the climate in the office, etc. When's best for your kit to go in, and obviously can it be compromised by you going in too early in terms of a build process? And then
right, I'm going to drop the bombshell here. I'm going to drop the bombshell here. Even newly designed and built buildings, they come with inherited inefficiencies in their design. I have worked, and sometimes I still work as an engineering consultant, and very often my colleagues design heating and cooling system oversizing them, because you cannot be blamed for for a boiler that is bigger than what is need to be, because it's always going to work, but you can't get blamed if they're smaller than the required capacity for the building. So this inherited inefficiency in building services transforms into inefficiencies and well, faulty operation of your system. Therefore, even if you have a new building, the application of our software will work as an insurance policy, where you make sure that from day one, the operation of that building, although it's new, brand new, and designed to the latest sustainability specs, is going to operate as it should, because it's not something that should be taken for granted. I could give you a massive list of building engineering projects that came with a CHP that was never run, simply because it was not spec'd for purpose. So the advantage of our system applies both to freshly built buildings as well as standing buildings, because they both have different problems, but these problems can both be solved by the use of our platform.
Okay, the reason I had a lecture once from I couldn't ever remember the fellow's name, but it was from one of your old employers, Borough Happold, and it was an overview of the ventilation of the Gherkin. Yeah. And he basically got to the end of the lecture. I think the Shard was in it as well before it was called the Shard. You basically got to the end of the lecture and said, but you just put people in it.
Yeah, exactly.
Everything I've told you is kind of irrelevant. So true. Just in relation to it going in new, would your system pick up? So something's gone in new, it's gone in with the spec, and then we add people, we cause a scene, we open windows, we argue about the radiator thermostat and whatnot. Your system's going to pick that up, or you can bespoke a system that would basically, you'd be able to draw the data out of a new build that wasn't working efficiently, and then you go in and find out it's because of all the reasons of the human interaction and new partitions and so on.
Well, obviously, if somebody requires 25 degrees in a room, they should be educated that 25 degrees is probably good for them, but very bad for the environment. So there must be some sort of internal policies that dictates, look, we designed this building to operate at 20 degrees, 25 degrees, any excess of temperature, we cannot accommodate for anyone. Yeah. But that said, our system is built in-house, so we developed everything within our software team, so it's highly customable or customizable. I don't know which one is the correct English word. So we can adapt our system to any scenario, as long as things can be monitored through a digital output. So we cannot control if people open the windows, if there is no sensors that notifies us of that. But if there is a sensor that tells that the windows are open, that information can be acquired by our system, as well as the operation of a pump, speed of a fan, supplier temperature, to produce the diagnostics we need to reduce energy consumption.
Fantastic, thank you very much. I can't see any more in the Q&A, so thank you very much for your time, Giovanni.
No problem, my pleasure.
A couple of little things to wrap up with. So yes, so thank you very much for your time, your expertise, and your presentation. It's very informative. As I say, nerded out a little bit, asking certain questions with a very limited amount of information from a previous life for me. So thank you for that. You answered excellently. So thank you to everybody for attending. Just a couple of last little points. We've got some listed events. On the 10th of Feb, we've got the Energy and Environmental Forum. That's a 10 o'clock start, and the title of that is Follow the Money. And the Eventbrite page and links where you'll have found this event and what's shown on the final slide there. If you go through any of those addresses, you'll be able to pick up and sign up to that event if not already. And on the 3rd of March, we're back on the lunchtime run, just like this one. And the title of that is Reducing Bills and Your Carbon Footprint. Fantastic. Thank you very much for your time, everybody, and we'll see you soon.